When a Ufer ground is installed, a supplemental electrode is required. The answer is yes, a supplemental electrode is indeed required. If a supplemental electrode is required, you do not need two rods. The Ufer ground serves as one of the required two electrodes. The other electrode can be a single ground rod, which must be at least 8 feet long and driven into the earth at least 6 feet deep. The ground rod must be at least 6 feet away from the Ufer ground and the foundation. The purpose of a grounding electrode system is to provide a low impedance path to earth, ensuring that electrical faults can safely be cleared and preventing dangerous voltage built up on conductive surfaces. The Ufer ground, also known as a concrete encased electrode, is a highly effective grounding electrode. It is constructed by encasing a length of bare copper conductor, typically number 4 American wire gauge or larger, within a concrete foundation or footing that is in direct contact with the earth. The large surface area of the concrete and the intimate contact with the earth provide a very low resistance path to ground. However, even with a Ufer ground in place, the National Electrical Code or NEC requires a supplemental grounding electrode. This is because the Ufer ground alone may not provide a sufficiently low impedance path to ground under all conditions. The supplemental electrode provides an additional path to ground, increasing the overall reliability and effectiveness of the grounding system. The NEC specifies several types of acceptable supplemental grounding electrodes. These include ground rods, ground plates, and other approved electrodes. A ground rod is the most common type of supplemental electrode. It consists of a metal rod, typically made of copper or copper-clad steel, that is driven into the earth. The rod must be at least 8 feet long and have a minimum diameter, as specified by the NEC. Ground plates are another type of acceptable supplemental grounding electrode. They consist of a metal plate that is buried in the earth. The plate must have a minimum surface area, as specified by the NEC. Other approved electrodes may include metal underground water pipes, metal frames of buildings, and other conductive objects that are in direct contact with the earth. The choice of supplemental grounding electrode will depend on site conditions and local requirements. Ground rods are generally the most cost-effective and easiest to install. However, in areas with high soil resistivity, ground plates or other types of electrodes may be necessary to achieve a sufficiently low impedance path to ground. The NEC specifies the requirements for the installation of supplemental grounding electrodes. These requirements include the depth to which the electrode must be buried, the distance between electrodes, and the size and type of grounding electrode conductor that must be used to connect the electrode to the grounding system. Ground rods must be driven into the earth to a depth of at least 8 feet. If rock bottom is encountered before the rod is driven to this depth, the rod may be buried horizontally in a trench that is at least 30 inches deep. Ground plates must be buried below the permanent moisture level, typically at least 30 inches deep. The distance between grounding electrodes must be at least 6 feet. The spacing is necessary to prevent the electrodes from interfering with each other and to ensure that each electrode provides an independent path to ground. The grounding electrode conductor must be sized according to the requirements of the NEC. The size of the conductor will depend on the size of the service entrance conductors and the type of grounding electrode that is used. The grounding electrode conductor must be made of copper or other approved material. It must be securely connected to the grounding electrode and to the grounding bus in the electrical panel. The NEC also specifies the requirements for the bonding of metal objects in the vicinity of the grounding electrode system. These objects include metal water pipes, gas pipes, and other conductive objects that could become energized in the event of a fault. Bonding these objects to the grounding system helps to ensure that they are at the same potential as the earth, reducing the risk of electric shock. When installing a supplemental grounding electrode, it is important to follow all applicable requirements of the NEC and local codes. This will help to ensure that the grounding system is safe and effective. Regarding whether the number 4 grounding electrode conductor can be run through bored holes in the tungstens to the panel, the answer is yes. A number 4 grounding electrode conductor can be run through bored holes in the tungstens to the panel. The National Electrical Code or NEC addresses the protection and support of grounding electrode conductors. specifically Section 250.64. C covers the requirements for grounding electrode conductors. This section allows grounding electrode conductors to be installed in or through framing members without needing additional protection, provided that the installation meets certain conditions. Firstly, the grounding electrode conductor must be securely fastened to the surface on which it is carried. This ensures that the conductor is not subject to physical damage or strain. Secondly, where the grounding electrode conductor is exposed to physical damage, it must be protected by one or more of the means specified in Section 250.64. These means include rigid metal conduit, intermediate metal conduit, rigid polyvinyl chloride conduit, electrical metallic tubing, or cable armor. However, if the grounding electrode conductor is run through bored holes in wood framing members such as tombstones, it is generally considered to be adequately protected from physical damage. This is because the wood framing members provide a degree of physical protection to the conductor. Therefore, it is typically not necessary to provide additional protection for the conductor in this situation. The NEC also requires that the grounding electrode conductor be installed in a neat and workmanlike manner. This means that the conductor should be installed in a way that is aesthetically pleasing and that does not create a hazard. The conductor should be run in a straight line and should be securely fastened to the framing members. The conductor should not be bent sharply or subjected to excessive strain. Additionally, the NEC specifies the minimum size of the grounding electrode conductor. The size of the conductor must be based on the size of the service entrance conductors. For a typical residential service, a number 4 copper grounding electrode conductor is usually sufficient. However, it is important to consult the NEC to determine the appropriate size of the conductor for your specific installation. In summary, a number 4 grounding electrode conductor can be run through bored holes and tombstones to the panel, provided that the conductor is securely fastened to the framing members and is installed in a neat and workmanlike manner. Additional protection is typically not required in this situation. However, it is important to consult the NEC and local codes to ensure that the installation meets all applicable requirements. Here's a more detailed breakdown of the relevant aspects of the NEC. Article 250 of the National Electrical Code or NEC is dedicated to grounding and bonding. Grounding electrode system requirements are detailed, including the use of the Ufer ground and supplemental electrodes. Section 250.52 outlines the electrodes that can be used for grounding. A concrete encased electrode or Ufer ground is described in 250.52. A3 and consists of at least 20 feet of bare copper conductor not smaller than number 4 AWG encased in concrete. Supplemental electrodes are discussed in 250.53. A3 requiring that a supplemental electrode be installed when a concrete encased electrode is used. Acceptable supplemental electrodes include ground rods, ground plates, and other electrodes specified in 250.52. A4 through A8. Ground rods and pipes, as covered in 250.53. She must have at least 8 feet in contact with the earth. If rock bottom is encountered, the rod can be buried in a trench at least 30 inches deep. Spacing between electrodes is also important. While the NEC doesn't specify a minimum distance between the Ufer ground and the supplemental electrode, it is generally recommended to keep them at least 6 feet apart to minimize interference. Grounding electrode conductor installation. Section 250.64 addresses the installation of the grounding electrode conductor, including protection and support requirements. Protection of grounding electrode conductor is outlined in 250.64. B. Specifying methods to protect the conductor from physical damage, such as using conduit or cable armor. Secure fastening is mandatory. The grounding electrode conductor must be securely fastened to the surface on which it is carried, as mentioned in 250.64. See size of grounding electrode conductor as per 250.66. Determines the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. A number 4 AWG copper conductor is often sufficient for residential services, but the code should be consulted for specific requirements. Bonding requirements are covered in 250.90 through 250.102, addressing the bonding of metal objects in the vicinity of the grounding system to ensure they are the same potential as the Earth. Other considerations includes local codes and regulations. Always check local codes and regulations, as they may have additional requirements beyond the NEC. Proper installation is critical, so ensure that all connections are made using approved methods and materials. Inspection is important as well. After installation, have the grounding system inspected to ensure it meets all requirements. The role of the Ufer ground is significant in ensuring electrical safety. The Ufer ground, being encased in concrete, benefits from a large contact area with the earth, which lowers the resistance to ground. This low resistance helps in quickly dissipating fault currents, thereby reducing the risk of electrical shock and fire. The concrete also protects the copper conductor from corrosion, ensuring a longer lifespan compared to grounding electrodes directly exposed to the soil. The supplemental electrode serves as a backup and complementary component to the Ufer ground. While the Ufer ground is highly effective, it may not always provide the lowest possible resistance to ground, especially under varying soil conditions or during dry periods. The supplemental electrode, typically a ground rod or ground plate, provides an additional path for fault current to flow to the earth, further enhancing the safety and reliability of the grounding system. This redundancy is crucial for ensuring that the electrical system remains safe even if one of the grounding electrodes becomes compromised. The spacing of at least 6 feet between the Ufer ground and the supplemental electrode is important for several reasons. Firstly, it helps to minimize the interaction between the two electrodes. When electrodes are placed too close together, they can interfere with each other's ability to effectively dissipate fault currents. The soil surrounding each electrode becomes saturated with current, reducing the overall effectiveness of the grounding system. Secondly, the spacing helps to ensure that each electrode provides an independent path to ground. If one electrode becomes damaged or disconnected, the other electrode can still provide a path for fault current to flow to the earth. This redundancy is essential for maintaining a safe and reliable grounding system. The proper installation of the grounding electrode conductor is also crucial for the effectiveness of the grounding system. The conductor must be sized appropriately to handle the expected fault currents. It must also be securely connected to both the grounding electrode and the grounding bus in the electrical panel. Loose or corroded connections can significantly increase the resistance of the grounding system, reducing its ability to quickly dissipate fault currents. When running the grounding electrode conductor through bored holes in wood framing members, it is important to ensure that the conductor is protected from physical damage. While the wood framing members provide some degree of protection, it is still necessary to take precautions to prevent the conductor from being damaged by nails, screws, or other objects. The conductor should be run in a straight line and should be securely fastened to the framing members. It should also be protected from abrasion or other physical damage. In addition to the requirements of the NEC, local codes and regulations may have additional requirements for grounding systems. It is important to check with the local electrical inspector to ensure that the grounding system meets all applicable requirements. Proper grounding is essential for the safety of any electrical system. It helps to protect people from electric shock and to prevent fires caused by electrical faults. By following the requirements of the NEC and local codes, you can ensure that your electrical system is properly grounded and safe. Remember that electrical work can be dangerous. If you are not comfortable working with electricity, it is best to hire a qualified electrician. A qualified electrician will have the knowledge and experience to properly install and maintain your electrical system, ensuring that it is safe and reliable. Firstly, always ensure that the power is turned off before working on any electrical components. This will help to prevent electric shock. Secondly, use the proper tools and equipment for the job. This will help to ensure that the work is done safely and correctly. Thirdly, follow all applicable codes and regulations. This will help to ensure that the electrical system is safe and compliant. Fourthly, if you are unsure about anything, ask for help. There are many resources available to help you learn about electrical safety. The Electrical Safety Foundation International, or ESFI, is a non-profit organization dedicated to promoting electrical safety. They offer a variety of resources, including educational materials, training programs, and public awareness campaigns. The National Fire Protection Association, or NFPA, is a non-profit organization that develops and publishes codes and standards for electrical safety. The website includes information on the National Electrical Code, or NEC, as well as other resources related to electrical safety. The Occupational Safety and Health Administration, or OSHA, is a federal agency responsible for ensuring safe and healthful working conditions for workers. They offer a variety of resources on electrical safety, including training materials and compliance assistance. By taking the time to learn about electrical safety, you can help to protect yourself and others from the dangers of electricity. Remember that electricity is a powerful force that should be treated with respect. Always follow safe work practices and consult with a qualified electrician if you have any questions.